So today I'll provide information on how we assess for data quality and why you should be looking at the data quality report, the results for the year 2013, and some of the challenges we face with the development of this report and how we plan on resolving those challenges in the near future. So how do we assess for data quality? How do we know our data is of good quality? And how do we know our data is precise and accurate? Well, we use EPA's measurement quality objectives. We use 1-point QC checks, precision checks, flow rate verifications, and performance audits. So what is precision, accuracy, and bias? Precision is repeated measurements that provide the same values. As you see in the first target, the shots are closer together. It's precise, but it's not accurate. This is where accuracy comes in. Measurement of a value to its true value. As you see in the second target, the shots are all over the place, but if you take an average of that, you see that the point is in the middle. It's accurate, but it's not precise. We want to be both precise and accurate with our information. Another thing we look at is bias, a persistent or systematic distortion in one direction. So our main goal with our data is both precise and accurate with minimum bias. So how do we assess for precision? For gases instruments, this is through a 1-point QC check where we look at the instrument's response with the known concentration of gas. And this is required every 2 weeks. And as for PM, this is through co-location. For PM samplers, we have two samplers operating near each other, and we look at the percent differences between the two samplers. I want to point out that EPA requires that 15% of our samplers be co-located. At this, you heard previously that we are not meeting that goal, but we are close. And another thing I want to point out is that PM10, continuous PM10 monitors, there is no co-location requirement. So how do we assess for accuracy and bias for gases instruments? Well, we look at the difference of the instrument's response with the reference gas. And for PM samplers, this is through flow rate verifications. You see a red oval. Since there's no co-location requirement for continuous PM10, EPA requires that we perform the flow rate and we upload that information to EPA's database. You see the blue ovals. There is proposed language that may require us to upload flow rates for the other samplers. Since the work has already been being done, ARB recommends that you upload that information because it helps us assess for bias and accuracy. Another area that verifies accuracy is performance audits. This is done yearly for gases instruments or semi-annually for PM. This could be done by ARB, South Coast, Bay Area, EPA, and other independent operators. And these are the criteria limits that we're not allowed to exceed for each pollutant. As you can see, ozone, we're not allowed to exceed 7%, 7% plus or minus 7% for bias, and 10% for accuracy when a performance audit's being performed. For PM 2.5, we're not allowed to exceed 10% for precision, plus or minus 4% for flow rate, and plus or minus 4% when a flow check is being performed by our audit team. So why should I look at the data quality report? Well, it's a tool. We identify areas where improvements can be made. We also make comparisons to other PQAOs, national average, on how well we are meeting federal criteria. So where do we get our information for this report? AMP 430 report, the data completeness report. I know you already heard this information from the previous presentation, but I want to point out a few things. The second site, you see for the whole year, only 71% of the information has been collected and uploaded. So this data will not be used for attainment. This is something we point out in our report. We also work with the district to help try to resolve the issue. We notify them, and sometimes there's information that's out there, but they simply forgot to upload that information. And this is something we work with. This is something we point out in our report. For AMB 256 report, I mentioned earlier that we're not allowed to exceed 7% for precision for ozone. And as you can see, we have a site. You might not be able to see it clearly, but there's one site that exceeded 7%. It's 10.32. This is something we point out in our report, and we try to resolve with the districts and the operator so it doesn't happen again, or they have data that could help resolve this issue. Same thing with the flow rate verifications. For continuous PM10, monthly flow rates are required. And as you can see, there's a few sites that did not upload the whole year's information. So now we're looking at the results for the year 2013. In ARB's network, we have 29 CO instruments operating. As you can see, over 90% have collected 75% or more of the ambient data. And if you look at the other PQAOs in the state, it's really good on the amount of information being collected and uploaded. For NO2, again, 52 instruments operating in our network, over 90% have collected and uploaded 75% or more of the ambient data. Similar story for the other PQAOs. Ozone, 106 instruments operating. Again, over 90% have uploaded and collected 75% or more of the ambient data. I mean, that's a lot of instruments, so that's really good that that information is being uploaded and collected. Sulfur dioxide, we have 15 instruments operating. Again, all the instruments have collected 75% or more of the ambient data. Similar story for the other PQAOs in the state. So what we're looking now is the precision and accuracy. Are we meeting the levels for precision and accuracy at the PQAO level? So on the right-hand side is, you can see by each pollutant and by the PQAOs that we are meeting the precision and the accuracy criteria. Information on the left is how much one point QC checks being uploaded. So again, we have 29 CO instruments in our state. 90% of them are uploading 100% of the 1 point QC checks. So we're now looking at PM. We have 106 samplers operating. Again, over 90% of the sites have uploaded 75% or more. For PM 2.5, we have 83 samplers. Again, over 90% have uploaded or collected 75% or more of the ambient data. So we're now looking at the results for PM. I want to point out that ARB is not meeting the co-location requirement, so this is based on information on the co-located sites that we have out in the field. As you can see for PM10, information is being uploaded, and we are meeting the precision criteria and the accuracy and bias criteria for PM10. But for PM 2.5, you can see that ARB's Bay Area and San Diego are having difficulties meeting precision criteria, but we are meeting the accuracy and bias criteria for PM 2.5. So this led us to look further. Is this something unique for the year 2013, or is this something we see with the other previous years? So we looked at the 3-year average, and as you can see, for gases, for all 3 years from 2011 to 2013, we're not having difficulties meeting federal criteria. But for PM 2.5, it's a different story, where we're exceeding EPA's criteria for precision at 10%, while our past 3 reading average is 20.56. So this led us to investigate further. Is something unique to California, or is this something we're seeing with the rest of the nation? And we compared our results with the rest of the nation, and we're looking at gases instruments. And at the site level, as you can see, no issues, there's no significant issues at all with gases. Overall, majority of the sites are meeting the precision criteria. However, it's a different story for PM. Across the nation, only 69% of the sites are meeting the precision criteria for PM10. For Region 9, only 50%. The PQAOs in the state of California are doing quite well, but PM 2.5 is a different story. If you look at the US average, 55% of the co-located sites are meeting the criteria. For Region 9, only 14% of the co-located sites are meeting the criteria. For ARB, 2 out of 11 of our co-located sites are meeting the criteria. South Coast has 2 out of 3 co-located sites that's meeting the criteria. So this lets us investigate, why is precision so difficult to meet for PM? Well, the statistics we use to assess precision is coefficient of variation, where we look at the percent differences of mass concentrations. So at lower concentrations, percent differences are magnified. And this leads to the cutoff limits. The cutoff limit for PM 2.5 is 3 micrograms per meter cubed, compared to PM 10, which is at 15 micrograms per meter cubed, a significant difference. So we take readings from 3 micrograms and above. So if you compare 2 results, let's say you got 2 readings, one is 3 and one is 4, that's a significant percent difference compared to 10 and 11. So we did additional analysis, and we compared, well, if we raise the limits, the cutoff limit from 3 to 6 to 9, how many sites were meeting the precision criteria? And we noticed that more sites were meeting the precision criteria. Another area that we are looking into is operational practices. Few of our sites that are meeting the precision criteria, we ask our operator, and one of the suggestions he made is making sure that both samplers are having the same flow rate. I'm not saying that's an answer, but I'm just saying that's something we're going to continue our investigation. So in summary, how well are we with our sites and our network? For gases, we are meeting the precision and accuracy and bias criteria. For PM, we're having issues with co-location requirements. We are, like Mike mentioned earlier, that we will be meeting that goal in the future. And for PM 2.5, we are not meeting the precision criteria at this moment. But compared to previous years, it is improving slightly. So if you see this asterisk for accuracy, this is based on limited information that's being uploaded. You saw, I'm sure if you remember that the blue ovals that we pointed out previously, we recommend operators upload additional flow rates because it helps us determine accuracy and bias. So some of the challenges we face with the development of this report is the network we have out in the field is not being represented in the database. There's issues with not correctly identifying POCs, not correctly identifying primary or secondary samplers, issues with closing the monitor dates, and all these issues lead to errors in precision, accuracy, and counts when we do our analysis. Another thing, we're going to continue our investigation for PM 2.5 precision. It's going to be an ongoing process, but we're going to still, in the future, we will get this resolved. So looking ahead, how we plan on resolving these challenges is offering training for staff to correctly identify POCs, correctly identify primary or secondary PM samplers. We're going to continue our investigation for PM 2.5. For future reports, we're going to add additional development tools to help digest the data that's being collected. For our report for the year 2013, we issued it in late December. We'd like to get the report out as soon as possible, maybe late summer, early fall. And we're also going to continue using a 3-year average to help us identify any data anomalies. The report can be found on our website, and I'll be able to answer any questions.
So I just want to, this report is really useful for QA managers to give you an assessment of how the PQA was doing as a whole. And in this year, we had, in addition to the report, you know, when you focus in, it's like, great, we're doing great as a PQO, but how are my sites doing? So we added an appendix to this year's report so you can actually get down to the site level to see how things are going at the site level and at ARB's PQAO level. We don't do it for the other PQAOs because the first question you always ask is, great for the network, but I want to know what sites are my problem sites. You saw that 90% of the ozone sites submitted data, had data completeness above 75%. Well, I want to know what 10% are not meeting that criteria. So that's what that appendix does, is it highlights those sites that need a little extra attention. So take a look at that report. It provides some very useful information. As Aman was saying, one of the goals is I want to get that report out sooner. We don't even start on it until after the data are certified of May 1st. So, and then when we're going through the report, we're trying to resolve all the issues, which tends to have us result in having to recertify the data, because there are a lot of changes that we make in AQS to properly reflect the data. But good tool. Hopefully you guys find it useful. We'll continue to put that out and make it available on our website. Thank you.